Okay, so the last video was on future value, and now we'll start on the problems for present value. Okay, so for number 17 in the homework, which for me is 11.1025, number 25 in the book. Remember, when you have an odd number in the book, that means there's an answer in the back of the book as well, right? Which is always nice. It means you can at least practice one and check it. Now they're asking us for present value, right? We know from before what future values were, right? And you just solve in that equation for P. And so this equation, for example, is on page 508 in your book. And it's presented as present value. What we do know is that A equals P times 1 plus R over N raised to the NT when we're talking about compound interest future value, right? So that was what we practiced mostly in the last video where we looked at future value. Okay, so now we are going to look at, we have achieved a value of $8,000. That was after 3 years and at a rate of 2.5%. 2.5% is 0.025, and we're using simple interest. Which for us, then we don't even use this formula yet, right? Simple interest was A equals P times 1 plus RT. And so here, our future value is going to be A divided by 1 plus RT. So here we have present value using simple interest. So you're just solving out of your old known equations. Right here, we have 8,000 divided by 1 plus 0.025 times 3. That is 8,000 times parenthesis 1 plus 0.025 times 3 in parenthesis 8,000. Oh, I hit times, not divide. Okay, so I got a value more, but we should have a value less. So let me try again. 8,000 divide by the parenthesis 1 plus 0.025 times 3. Okay, that's better. So we have Polya's fourth step, right? And I originally got a value larger than 8,000. But 8,000 is the future amount. So we should certainly have smaller than A, right? As just an internal check, right? Which I originally did not have, so I knew I did the problem incorrectly. Now I've done the problem correctly by actually dividing here, and I get $7,441.86. Should be the present value. Or another way of looking at it is that should be the amount we deposit in order to achieve 8,000 in the future, right? Now, unlike in the last video where we used the number of days in the year as 360, for continuous compounding, we use 365 days. But the problem reminds us of this, so that's nice of them. So number 18 in your homework is number 28 in the book. Find the present value using the present value formula and a calculator and 365 days in the year for compounding continuously. So we know A equals PERT for compounding continuously. They want us to find P. So P is A divided by E to the RT, right? Because we're solving for P in the known equation. They tell us that this time around, we have a future value of $225,500 at a rate of 8.85%, which for us in decimal form is 0.0885, compounded continuously for 8 years and 135 days, which is 135 out of 365 days per year, which gives us a value. I usually like the improper fraction. So 365 times 8 plus 135 gives me 3055 over 365. Let's see if this is a decent number. It is not, so we'll just leave it in fraction form. And then we'll fill in our equation, right? We have A, which they gave us, 225,500, and then we'll divide by E, which is raised to the power R times this fraction, right? So I think I'm just going to do that on the side here, maybe for some simplicity. 3055 divide by 365, hit enter, multiply by 0.0885, hit enter. I get this 0.74073 2867. And so I hesitate rounding it all. If you do, you should have at least 5 digits of significance. Let's see if that gets me close enough to the answer. 225,500 divide by E, which is raised to the 0.74073. Oh, I'm off by 30 cents. So let me not round at all, right? I'm just going to stick that whole number in there. Not whole number, but I'm going to stick the entire number. So 0.740732867, right? I'm going to stick that whole thing in there. 225500 divide by E raised to the 0.740732867, and that gets me to the correct answer. So without any rounding, I get 10, 7, 5, 10, and now 30 rounded to the 37th cent. So I need to deposit, right? This amount should be less than A. It is, right? So I need to deposit $107,510.37 in order to have 225,500 in the future, right? So we're just doing kind of the opposite that we were doing last time. Last time we were finding A, right? This time we're finding P. In number 19, which is number 501 XP in our book, we have how much would you have in 8 years if you purchased a $1,000 8-year savings certificate that paid 2% compounded quarterly? Okay, so clear this drawing. We have number 501 XP, which is your number 19. How much would you have? So that's a future value. How much would you have in the future in 8 years if you purchased a $1,000 8-year savings certificate that paid a rate of 2%, which in decimal form is 0.02, compounded quarterly. So N is 4 because we compound quarterly, quarter, right? 4. And we are using our compound formula for future values. So A equals P times 1 plus R over N raised to the NT. So we might want NT, right? 4 times 8 is 32 years. Well, it's not 32 years, it's 32 compounding periods. So let's do our plug and chug. 1,000 times 1 plus 0.02 divided by 4 raised to the power 32, right? So if I stick this in the calculator, 1,000 times parenthesis 1 plus 0.02 divided by 4 in parenthesis caret 32, I get the value in dollars of $1,173.04. Number 20 for you is number 56 for me. They give us the compounding formula. So we'll go ahead and write that down. And then it reads, on August 8th, we might need some of this, 1981, American Savings offered an insured tax-free account paying a rate of 23.24% compounded monthly. Oh, monthly. Well, so N equals 12. If you had invested, so if you had put in the amount of $80,000 at that time, how much would you have on August 8th of 2014, assuming that you could have locked the interest rate at the time of the deposit? Use the formula given. So what is T, right? T is then 2014 take away 1981, right? Because that was like the year span. So what do we have here? 3, so 33 years. Just double check. 1981 plus 33 years would take me to, oh no, I think I got too many. Right, so 23 years. Oh, there's no carry the one, Angel. Okay. I was like, what am I doing wrong here? I cannot count. Try to double check myself. Instead, I confused myself. But anyhow, 1981 plus 33 is in fact, don't carry a one. There's no need, right? Now we carry a one. Thank you. 2014. Okay, so 33 years. And what else do we have? Just to plug and chug it now? Well, we could do NT, right? Because that's a big number, 12 times 33. Oh, that's 396 compounding periods. So if we were to start our plug and chug, then we have 80,000 times 1 plus 0.2324, right? Divide by 12, raised to the exponent 396. When I stick this in the calculator, I type 80000 times parenthesis 1 plus 0.2324 divided by 12 in parenthesis caret 396, hit enter. I've got a huge value, huge, 159,198,689, and I got 90 cents. 2.2324 divided by 12. I'm off by 5 cents, but I don't see why. Right, so the book has a 5 here, so I'm 5 cents off. But I stuck it in the calculator as you see here. So maybe my 396 is wrong. Let's see. 33 times 12, that's 396. I typed in 96. 2324. Yeah, so I don't know. But the book and I are off by 5 cents of each other. There's usually an allowance as to how wrong you can be. For example, let's see. They got 5 cents more than me, so I don't think maybe rounding is the issue because it seems like the mistake would go in the other direction. Okay, so on number 21, which is 37 A, B, C, and D in your book, you have to find the cost of these items due to inflation. So we have a cup of coffee that costs $3.75. We have paper, newspaper that costs $2.75. We have a Big Mac that costs $4.10. And we have a gallon of gas that costs $3.75, which is the same as A, right? So we don't necessarily have to do that one twice. The problem, which is for me, number 37, for you, number 21, the problem is in compounding continuously. So we have P times E to the RT exponent. We're also told that we're looking for the cost of these items after 8 years and that the inflation rate is 9%. which is a 0.09. And we're supposed to round to the nearest cent, right? So if we use the formula on each of these, then we have 3.75 times e to the power, well, we could multiply RT for each of these, right? That would be a 0.72. Let me double check. So 8 times 0.09 is 0.72. So we're just going to raise each of these to the 0.72. So this is 3.75 times e to the 0.72. And that gives me $7.70, which then for this one is also $7.70, right? And for each of these, we just change what P is to 75, but it's the same inflation period with the same rate, and 410 with the same inflation period and the same inflation rate. So we just plug and chug those through. 2.75 times e to the power 0.72 gives me a $5.65 newspaper. And at 410 times e to the 0.72, oops, sorry, I got to assure myself there. We have a Big Mac, which costs $8.42. Now we just have the next one, right, which is almost exactly the same. We've got movie admission, a CD, a textbook, and an electric bill. We've got a 10-year rate for this next one, which is number 38 in the book. So I'm going to erase some of this and just write in what I need to change, right? So in number 38 in the book, we now are looking at 10 years, right? And so that's going to change our RT value to 0.9. We also now have new items to explore. This time around, we have a $7 movie ticket, a $14.95 CD, $130 textbook, and an electric bill of $135. This time around, right, we just have to put in 7, 14.95, 130, and then this one we actually have to solve 135 e to the 0.9 exponent, right? So our first one is 7 times e to the 0.9, which gives me a $17.22 movie ticket. Now we have 14.95 times e to the 0.9 gives me a $36.77 CD. We have 130 times e to the 0.9 for a $319.75 textbook, which means our electric bill is going to be even higher. 135 times e to the 0.9 gives us an electric bill of $332.50. right? So we are compounding continuously on those number 37 and 38. Now for number, let's see, 24 to you is 42 to me. So let me clear this one out. So 42, for you it's 24, for me it's 42. Suppose you see a car with an advertised price of 15,600 at a monthly payment, so I'm gonna call it MP, of $410.83 for 4 years, which is 48 months, right? Monthly payments. So what is the amount of interest paid? I don't even know if we need that. Let's see. So the amount of interest paid, if we pay $410.83 for 48 months, right? Then we pay a total of $19,719.84, right? The amount of interest then will be to take away the purchase price of 15,600, and then we'll know how much they're charging us in interest, right? So they're charging us a total of $4,119.84 in interest, right? Where we have here I equals A minus P, where simple interest came to us as A equals P plus I, right? So therefore I equals A minus P. This was another version of A because it was our monthly payments times the number of months, right? So it's actually the future value divided by N times the number of months, right? So that's what we did to find A here. And then this is what we did to find I, in case you wanted to know where the formulas were and not just have some intuitive conversation, right? Okay, so number 25, which is number 43. Suppose you buy a home and finance $295 at a monthly payment of $2,233.17 per month for 30 years. 30 years, how many months is that, right? The number of months in 30 years, that would be 360 months, right? So A is the monthly payments times the number of months, right? So 2233.17 times 360. That gives me 803,941.20. That's the future amount, right? So to find I, the interest that we're paying, we're going to take future amount and subtract from it the purchase price, right? So 803,941.20, take away 295. Oh, they're charging us a lot. A terrible amount. So the interest that they're charging us is $508,941.20, right? Ooh wee. All right. And the last couple of problems, right? We've got number 27 and number 29. Number 27 for you is number 47 in the book, right? So number 47 in your book is, suppose that an insurance agent offers you a policy that will provide you with a yearly income of 40,000 in 30 years. What is a comparable salary today? Assuming inflation rate of 6%, which is 0.06, compounded annually, which is n equals 1, right? So they're asking us for the present value, right? We have the A equals P times the quantity 1 plus R over N to the NT exponent. And so P is to divide both sides by the 1 plus R over N to the NT, leaving us P equals this expression here. The future value is the 40,000. T is the number of years, right? We have our rate there and our N. So now we just need to plug and chug 40,000 divide by the quantity 1 plus the ratio 0.06 divide by 1 raised to the exponent of NT, so just 30 here. So we have 40,000 divide by 1.06 raised to the power 30. So I'm going to type in 40,000 divide by 1.06 caret 30, and I get in dollars $6,964.41. So if you're making this now, that's the equivalent to making $40,000 in 30 years. And then the last question asks us to find time, to find T. So your number 29 is 51 in the book. So let's clear this out. We've got number 51 in the book. Calculate the time necessary to achieve the investment goal. Give your answer to the nearest day. Use the 365 days of the year model where we have simple interest. So simple interest has a future amount of P times 1 plus R times T. This problem gives us a future amount of $1,000, a rate of 7%, which is 0.07 in decimal form, a time frame that we're looking for, and a deposit of $750. So if we're going to solve for T here, right, we can divide both sides by P to have 1 plus RT, right? We can subtract 1 from both sides to have RT. And now we can divide both sides by R, right? If we so chose. And so in the end, we would have a t that equals a divided by p minus 1, which itself then is divided by r, right? So that was just solving for t first. We could have, of course, stuck all the numbers in here and then solved, right? Which is fine. I'm going to erase some of this so that I have some space, right? And I'm going to write our stuff, right? So we have 1,000 divided by 750, and then we'll take away 1. And from that quantity, we'll divide by 0.07. Okay, so 1,000 divided by 750 gives me 1.33333. Take away 1, and that gives me 0.333 forever, right? I'm not going to change it in the calculator. I'm just going to subtract 1 in the calculator. 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Divide by 0.07. So I left alone in the calculator, and now I'm dividing by 0.07, which gives me a value of 4.7619,04762, which is 4 years, right? So let me erase the formula here, right? This is in years, so we have 4 years. And they want to know how many days, right? So we have 0.76 of a year, but how many days is that, right? So if we take the 4 years out and leave the 0.7619,04762 and multiply by 365 days, then we'll find that to be, oh, sorry. I think I started mixing things there, right? We have 4 years plus 0.7619,04762 times 365, which amounts to, 278 days. So the answer that your computer program is looking for is 4 years, 278 days. And that's the end of the homework for section 11.1.